Hello everyone, myself Ankaseti and I am from Networkers Home Technical Team. Today we are discussing about the BGP. BGP is Border Gateway Protocol. In the BGP, we are discussing about IBGP and EBGP. We are considering about this BGP. So we are having this BGP configuration. In this BGP configuration, we are having two ASs. One is AS100 and other is AS2345. R1 is connected to R2, R3, R4 and R5. R1 is in AS100, R2, R3, R4, R5 is in AS2345. Now, R1, we have given the IP on all the interfaces. So now, first we have to do the OSPF configuration. Means R2, R3, R4, R5, we have to do the OSPF configuration on these interfaces. This R2. So on R2, we'll use this command router OSPF, that is 2345. Then we have to use exit. Then we have to use interface range R2, R3, R4 and R5. We have to first use OSPF in between so that each network, or we can say each network, can be accessible from one router to another. So router OSPF 2345, or we can say first we have to use the router ASPF. We have to use router OSPF 2. Next is we have to exit this. Now, interface range, we have to take interface range 1 by 0, 2 by 0, 1 by 1, and we don't have to take these interfaces. We are not configuring R1, R2 in OSPF and R1, R3 in OSPF. Okay. So interface range, fast Ethernet 1 by 0, fast Ethernet 2 by 0, and fast Ethernet 1 by 1. Loopback 1. Loopback 1. So IP OSPF to area 234. Now do show IP to show IP OSPF interface. So you can see we are having 1 by 0, 2 by 0, 1 by 1 and loopback 1 in the OSPF enabled. We have enabled these interfaces into the OSPF. Now we'll move on to the R3. On R3, fast Ethernet 1 by 1, 2 by 0 and 1 by 0 and loopback 0 we have to give in the OSPF. So the command is router OSPF and 3 and exit, and we have to select the interfaces, interface range, fast Ethernet 1 by 1, fast Ethernet 2 by 0, fast Ethernet 0 by 0 and loopback. So IP OSPF 3, area is 234. Next, now to show IP OSPF is, so all are in the interface area 2345. I will move on to R4. So router OSPF is 4, exit, interface range, let's see, 1 by 0, fast Ethernet 2 by 0, fast Ethernet 1 by 1 and loopback is 1. Now exit. Sorry. So IP OSPF 4 area is 234. Now exit. Now on R5, we have to move on R5. So same commands here, router OSPF 5 and exit. Now interface range FP 1 by 1, fast Ethernet 2 by 0, fast Ethernet 0 by 2, and loopback 1. So IP OSPF 5 area is 234. Okay. So, exit. Now, on R2, can we be able to ping 5.5, or do we have the roots of 5.5 network? Sure, I see. Now, can you swipe it out? And yes, loop back 5.5 is available in the net. So can we be able to ping on 5.5.5.5? Yes, we can able to ping. Now, we can able to ping here. Now, so R2, R3, R4, R5. These all are in area, or we can say AS2345. So these all are in AS2345. So we have to make IBGP neighborship. IBGP neighborship can be formed directly, or IBGP neighborship can be formed with the help of peer group. If IBGP neighborship is there, so we are having 4 routers, 2, 3, 4, 5. These 4 routers, we have to form the IBGP neighborship. To form the IBGP neighborship, if we have to form it individually, so how much neighborship we require? The formula is n into n minus 1 by 2. So 4 into 4 minus 1, that is 4 into 3 by 2 is equals to, they form 6 neighborship with each other. But with the peer group formula, we can do it easily. But today we are going to use the peer group formula, peer group method. So what is the peer group? It makes IBGP neighborship easier to configure. This config router BGP, and that is 234. Router BGP 2345. Now, next is we have to form neighbor. Neighbor is, so we'll use one command, that is we have to use a tag. A tag means to say we have to give a tag to all the neighbors. So the neighbor is, let's give the tag, and the tag is case sensitive. So you have to understand that all the letters are case sensitive. So CC, that's how we do the tag. We'll name the tag as CCNP. Neighbor CCNP, and now you have to give a peer group. Neighbor CCNP peer group, and neighbor CCNP, and we have to give the remote A. The remote AS is 2, 3, 4, 5 for everyone. Now the remote is AS, we have given the remote AS. So now we have to give neighbor. Neighbor is from R2, we are having the neighbor 3, 4, and 5. So neighbor is 3.3.3.3, and the peer group is for neighbor 3.3. Neighbor 3.3. Peer group is CC, and neighbor 4.4. The peer group is CC, and peer group is CCNP. Neighbor 5.5. The peer group is CCN. Now, so first we have given, so all the neighbors are being given in this CCNP peer group. So now neighbor CCNP, and we have to use update source loop back 1, because all the neighborship, we have done the neighborship with the help of loopback. Okay, we are going to make the neighborship with the help of loopback. This one. So exit, and now we have to give all these commands on all the routers. Do show. Okay. So we have to copy this command and paste this command on all the routers. So first we'll use the notepad. On the notepad, we have to first copy these commands, copy, and we have to use the notepad control. So now R2 is the neighbor of 3, 4, and 5. R2 is the neighbor of 3, 4, and 5. Now R3 is the neighbor of 2, 4, and 5. So on R3, we have to remove this as 2.2.2.2. So Control A, copy this and paste it on the R3. 2 we have given on 3. 3 is not there, so done. On 4, we have to remove 4.4, so we can use here as 3.3. Control A and copy, and on 4 can use this. And on 5, 5 is not there. We are having 4.4.4.4. Controlling copy. We can use 4.4.4. So now on R2, we have to check show IBGP. So now neighborship is up for all the routers. 2 is having the neighborship with 3, 4, and 5. Because here the prefix received is 0 and state is nothing is shown here. So state is now we are the neighbor. So R2 is neighbor with R3, R4, and R5. Similarly, we'll check on these interfaces show IP, BGP, and sub. Here also 3 is the neighborship with 2, 4, and 5 on R4. So IP, BGP, summary. R4 is neighborship with 2, 3, and 5, and on 5 show IP, BGP, 2, 3, and 4. Clear? So now on R2, we can use the command show IP route. You can see that 5, we can able to ping 5. Okay. Ping 5.5.5. Okay. We can able to ping 5. On R2, we can able to ping each and everyone. So now we are having the BGP neighborship with 3, 4, and 5. Now R1 to R2. So now we have to this IBGP neighborship is being formed. So now we have to form the neighborship between R1, R2 and R1, R3. R1. First, show IP interface brief and exclude unassigned. So we are having this neighborship that is path Ethernet 0.0, it is 12 and it is 13 and loopback is 1.1. So we'll make on the router BGP and that is 100. Now, first we have to give the network for R1, we have to give the network of 2.2. First we check show IP. We are not having the network of 2.2. So BGP neighborship can't be formed. So first we have to make the neighborship, we have to give the roots of 2.2 and 3.3 in this R1, and on R2 and R3 we have to give the neighborship of 1.1 and 3.3. So on R1, what is the command? Command is on the IP route. IP route is on R1 we have to give 2.2.2.0 and 255.255.255.0. That is the subnet mask, and the next hop is 12.1.1.2. Clear? Now on for 3.3 you have to give 3.3, and the next hop is 13.1.1. That is this interface. This interface is on R3 ZAP 1/0. The interface is 13.1.1. Now we have given the route on R1. On R2, R3, we have to give the route static routes of 1.1. On R2, first or 3, IP route that is 1.1.1.0 to 55.255.255.0, and the next hop is 12.1.1. And on R3, IP on R3 conf IP route. IP route is on R3. IP route is 1.1.1.0 to 55.255.255.0 subnet mask, and then the next hop is 13.1.1. Okay. So now on R1 we are having both routes towards R2 and R3 with help of this command show IP inlet. Show IP route we are having 1 networks and 3 networks. Okay. So now on R2 show IP route. On R2 we can see 1 network is there. So on R2 we can see 1 network is there, and on R3 with show IP route 1 we can see 1 network is there on R3. Okay. So now on R1 we have to form a BGP neighborship. So how we can form? On the first towards R2. So router BGP 100. Now neighbor is 2.2.2.2 and remote AS is 2345. And then we have to give this command and update source loopback 1, update source loopback 1. Okay. Now, and similarly, this command on R2, we have to give this command. On R2, we have to give this command on R2 also. R2 router BGP, and router BGP 2345, and neighbor is 1.1.1.1, and remote AS is 100. Remote AS is now neighbor this, and update source loopback. Okay, here we have also given this update source loopback one, but neighborship is not found. Why? Because in EBGP neighborship, we have to give one more command, that is EBGP multi-hop command. EBGP multi-hop. So we can give multi-hop as 2. Okay, and on R1, we have to give EBGP multi-hop 2 command and errors. Okay, now the neighborship is being formed. Show IP BGP. Show IP BGP. So okay, so on R1, the neighborship is being found towards R2, and on R2, we have to take show IP BGP summary. So now here also the 1.1 neighborship is being formed with the AS 100. Neighborship is being formed between R1 and R2. Similarly, on R1 and R3, we have to form the neighborship. So what are the commands? The command is on the router BGP on R1. We are having router BGP 100, and the neighbor is 3.0.0.3, and remote AS is 2345, and then is update source loopback 1, and the last is EBGP multi-hop is 2. EBGP multi-hop is okay. Now EBGP multi-hop is 2. So on R3, we have to give similar commands towards R1. First is router BGP 2345, and neighbor is 1.1.1.1, and first is remote AS. Remote AS is 100. Okay, and then is update source loopback 1. Update source loopback. Last is EBGP multi-hop. EBGP multi-hop and close. Now, in check on R1. Show IP BGP. So IP BGP summary, we can see that we are having the neighborship with 3.3. So now on R1, on R2, on R1. Okay. So can we be able to ping 2.2? Ping 2.2.2. We can able to ping. Can we be able to ping on 3.3.0.3? Yes, we can able to ping on 3.3. Can we be able to ping on 4.4.4.4? No, we can't able to ping 4.4.4.4. So what is the reason? The reason is on R1, we do not have the routes for 4.4 network. Show IP. So you can see they are not having the routes for 4.4 and 5.5 network. 4.4 and 5.5 network. So on R1, let's suppose on R1, we'll give a default route towards R2. Okay? We'll give one default route, that is 0.0.0.0, 0.0.0.0, and the next hop is 12.1.1. Okay? So now, can we be able to ping on 4.4 now? Do ping 4.4.4. No, we can't able to ping 4.4. Why? Because on R4, we'll not know where is the network 1.1.1.1. So now you can see this is R2, R3, R4, and R5. Which network is this? This network is IBGP network. So on R2, we have given, on R2, we have to give the default route. Where we have to give the default route? On R2, we have to use the command default information originate. Why? I'll tell you. On R2, first we have to use this command router here, and that is 2. Next is default information originate on default information originate on this. Now when we go on R4, we use the command show IP route. You can see for external network, we have to go by 24.1.1.2, and this is the 24.1.1. So now, can we be able to ping 4.4.4.4 network? Yes, we can able to ping 4.4 network. We can also be able to ping 5.5. So this is the configuration of IBGP and EBGP neighborship. Hope you understand, and thank you for watching.